Welcome back YouTube, this is Dynamo MK or Moäz Kassar here once again, and for today's video we will be looking at the distance formula between any 2 points. For example, we have 2 points over here. We'll call this point 1, which is 10, 7, and point 2, which is 1, 1. And also notice we have a straight line going straight between these 2 points, and the length of this line is the length that we want to figure out. This is the exact distance between the 2 points that we're trying to figure out. So let's get straight into this. The first thing you want to do is you want to draw a certain line. You can either draw it vertically or horizontally. It just has to be a perfectly straight line, and it has to go in the direction of the other point. For example, we could take this line over here, or this line, or laser line segment over here. I'll choose this one just because why not. And then after that, you'll notice that you have 2 loose ends, one that's still the other point and the other from the line segment you just made. So you want to connect them together like this. And if you did things right, you have a right angle. Also, I know that this isn't exactly a right angle. However, bear with me. This is supposed to be a right angle, and so long as you can get where this line segment, or rather these line segments are supposed to be, you should be good to go. So now after this, we need to figure out the coordinates of the point over here. If we notice, this has the same x-coordinate as one of our 2 points. In this case, it has the same x-coordinate as this line over here. Seeing as this doesn't move to the left or right of this point, this is exactly on the same x-coordinate, so we'll say 1 here. And likewise, it takes the y-coordinate from the other point. This point isn't above or below this point over here. So that's why the y-coordinate comes from here. So we have 1, 7. So after that's done, we can take a look at a very neat property of all right triangles. This is known as the Pythagorean theorem. Basically, it says that a squared plus b squared equals c squared, where if we make the 2 line segments next to the right angle, A and B, and I'm drawing these in different colors to make them a little easier. We get that c squared is equal to a squared plus b squared. So then that's lovely. We know already that we can rewrite this in a different way. We can essentially, c is equal to the square root of a squared plus b squared. And I'm doing this because we were looking for c. C is the length of the line between the 2 points, and it is the distance between them. So then all we need to do now is figure out what A and B are in relation to our 2 points. So we're going to start with B, though it really doesn't matter. To figure out what B is, we'll need to take a look at the 2 points here. This one and this one. If you notice, one of the coordinates, namely the y-coordinate, is the exact same between them, and the x-coordinate of this point happens to match the x-coordinate of point 2. Notice then that this means that we have here x2 And here we have x1. With that, we can do x1 minus x2. Traditionally, people would like to do it the other way, x2 minus x1, though it really does not matter. And in this case, we get 10 minus 1, which is equal to 9. So then we'll say here that that's equal to the square root of something plus 9 squared. Let's take a look. Actually, let's draw it underneath so it looks a little more concise. So now let's take a look at the A side over here. We know that this y1 is the same as the y coordinate over here, because this y coordinate was taken from point 1, and it's also connected straight to point 2, so we'll take y coordinate of the second one, so that'll be equal to, in this case, y1 minus y2. In this particular case, we get 7 minus 1, which is equal to 7 plus 1, which is equal to 8. So now we have an 8 squared plus 9 squared. And after this, we can just take the next step of squaring these, so we would have 64 plus 81, which is equal to 145. And there you have it. This is the distance between these 2 points. And if you want like a general takeaway formula, this would be equal to, we'll say x1 minus x2 squared plus y1 minus y2 squared. Sometimes you'll see these swapped around. Some people like saying y2 minus y1, though realistically it does not matter considering you're squaring them, so the difference between them would be lost to the square. And as this video shows, we already have a way of figuring out the distance not only between these 2 points, but between any 2 points. In fact, this works very well between any 2 points, that they don't just have to be in 2 dimensions. You can have 3-dimensional points and have that work too. For example, 1, 3, 5, and 7, 2, 4. Yes, these are both 3-dimensional points, as you can tell with an x coordinate, a y coordinate, and a z coordinate. And in just a few seconds, we will be going into part 2 of this video, which is going to explain how to calculate things in 3 dimensions. And so now let's do part 2. If you notice here, I already drew not just the first 2 points over here, but also the 2 middle points and the 3 line segments that come in between. Now y3, well, very simply, we're in 3 dimensions now, and so there's 3 different directions we can go. Up and down, left and right, forward and backward. And it also means that because of this, the perspective here might not make it look very clear, but these are exactly right angles. And so how do we use this then to figure out our right triangle. We want just one right triangle, but it looks like we can make two. And indeed we can. The first step of figuring out how to do this is to generate these two middle points and then the line segments that connect them. To figure out this first middle point over here, you start with point A or point B, whatever. You take two coordinates from point A. If you notice, I took the x and y coordinates, which are 1 and 3. But then you take the z coordinate from point B. Again, you don't have to do it in this order. You can just do, for example, if you wanted to, you could do 7, 3, 5. Just take these two and this one. It doesn't really matter. However, now that we've done that, we have our first middle point. After that, we figure out another point that we want to take from there. We have 1, 3, 1, 4, 1, 2, 4, and 7, 2, 4. I chose to change the y coordinate next, though it realistically does not matter as long as you changed a different one than the last one. And then once you did all that, you put the straight lines in between these points. That, or you do what I did and tell a machine to do it, since my ability to draw in 3D is not at all something I want to present on my videos. But yeah, once we did all that, we can get on to the next step in this problem. We can use one of two right triangles that we want to solve first. Now, neither of them is the final right triangle that we want. However, we still need one of them, and I'm going to choose this longer one, and then here's why. If you want to know something, this is also a right angle. Sure, this is a diagonal line, but because it's on the same plane as this line segment over here, and that makes a right angle with this line segment over here, we can geometrically say that this new line segment is also the same exact case. So then we have ourselves an A, a B, and a C. This is our A. This is our B. And then we have our C already. But then how do we figure out the length of this B? Well, we very simply use the tricks used in the last video. More specifically, we can notice that the 4 is actually the same in all 3 points of this triangle, so we can kind of exclude it for now. It'll be important later, for now, we'll put it to the wayside. So then we have a triangle with coordinates 1, 3, 1, 2, and 7, 2 for its points. So we're going to have like a lowercase a, lowercase b, and uppercase b as our triangle. And to adjust the Pythagorean theorem for that, uppercase b squared is equal to lowercase a squared plus lowercase b squared. And to figure out what lowercase a is, we notice that 1 and 4 are the same as the x and z coordinates of these 2 points, but the y coordinate is different, 2 and 3. So therefore we have 2 minus 3, which is minus 1. Also notice that this is actually the same as y1 minus y2, or technically y2 minus y1, but the order doesn't matter considering that we will be squaring this later. So then we know that this is going to be equal to y1 minus y2 squared plus what b, we'll notice, has a very similar case. This time it's the x coordinates that are different, so then we know that x1 comes from point 1 over here, and x2 comes from point 2 over here. So we can say that x1 minus x2 is equal to 1 minus 7, which is equal to minus 6. Again, I know a negative number, but the actual length of the side is positive 6. And plus, we're going to be squaring this, so the negative sign will disappear. So then we have x1 minus x2 squared. And so in order to get just b, we'll say b is equal to the square root of x1 plus x2 squared plus y1 plus y2 squared. However, we don't actually need just regular b by itself, considering b squared is the only thing that's going to be important. I'm just going to erase all of these and make things a little easier. And in terms of the actual numbers, this is going to be equal to 1 squared plus 6 squared, which is going to be 1 plus 36, which is going to be 37. Yes, that is our b. Now we'll focus on a right now. And a is a lot simpler to calculate. We already know that the x and y coordinates are the exact same here, so the only thing that changes is the z coordinate. This is z1, and this came straight from all the way over here, so that's going to be z2. So we're going to say that a is equal to z1 minus z2, which is going to be 5 minus 4, which is going to be a 1. So then let me write that down here. A is equal to z1 minus z2 is equal to 5 minus 4, which is equal to 1. And so now let's tie all this together. C is going to be equal to the square root of a squared plus b squared. We already know that 1 squared is 1, so we'll just put a 1 over here, plus 37. And so that gives us our answer of the square root of 38. That is our C, right over here. And also you'll notice, if you pay attention, this is also the same as the square root of, and if we look at the b we came up with earlier, rather b squared, that was this long thing, x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. So if you notice, we still took something like this thing over here straight from when we were doing 2-dimensional points, but then we added this little thing to it because we're working in 3 dimensions. And in case you're wondering, if you wanted to go into something like 4 dimensions, that's exactly how it works. You can just extend this a little more. You can say, if you want to choose w1 minus w2 squared, and that's how you do 4 dimensions. If you want, you can do this for any number of dimensions. You can do this for like 10 dimensions if you want. You can do this for like 57 dimensions or even a billion dimensions if you were really crazy. I know it might seem absolutely ridiculous to go higher than 4 dimensions, since very rarely will people ever want to do that. However, this method works. It works for 2-dimensional points, 3-dimensional points. It can work for any number of dimensional points. so long as that number is a positive integer. Anyhow, this has been Moäz Kassar, and I hope you enjoyed this video. If you did, please leave a like down below, comment and share, and all that other cliche things that you hear so many YouTubers saying to do at the beginning of the video. However, more importantly, if you didn't like this video, please let me know in the comment section below, or however you want to tell me, how I can improve my content, what you want to see changed in it, so I can know to make better content for the future. In any case, I genuinely hope you had a great time here, and this has been Dynamo MK or Moäz Kassar. In any case, I shall see you later. Ciao!